In this video, we're going to estimate small and large values using powers of 10. So oftentimes, we can estimate very large and very small values using a power of 10. First, in order to do that, we need to be able to rewrite these really large or really small values. So I'll show you a way to do that in just a couple of steps. What we're going to do is rewrite each of these values as a single digit times a power of 10. So as I look at the values, I'm going to look at the largest place value that is a non-zero number. So for A, that would be here, the 2 representing 20,000. And then I'm just going to look to the digit to the right of it to see if I would round up or leave it at 2. Because that digit is a 4, I would round this to 20,000. Now I can write that using a power of 10 by converting it into scientific notation. So I know that that would be 2 times whatever power of 10, and we get that power by counting the number of places we would move the decimal. 1, 2, 3, 4. Okay, so that's what I would estimate using a power of 10 for that first value of 24,000. We could say it's about 2 times 10 to the 4th power. Let's do a couple of more. Looking at B, we have this really small decimal, and in the largest place value, the non-zero digit is that 8. When I look to the right of 8, the 7 tells me that I can round that up to a 9. So I'm first in standard notation rounding this up to a 9. Now I'm going to write it as a power of 10 by converting it into scientific notation. So I can see that we can estimate that very small decimal by saying that it is about 9 times 10 to the negative 4th. And one more example. 6,825,000. And the largest place value is the 6, and the 8 tells us to bump it up to a 7. So I'm rounding it so that I can then write it as a single digit times a power of 10. And for this one, I can count that it would be times 10 to the 6th power. Let's read this example that says, in 2015, the world population was about 7,390,000,000. In the same year, the population of the country that Rhett lived in was about 6,926,000. Part A says, give an estimate of the world population in 2015 using a power of 10. Okay, so the world population is this value here. And remember that using a power of 10 means that we want to write that in scientific notation. So we want to first round that value. So I would round that by looking at the largest place value to about 7 billion. In scientific notation then, or in other words, using a power of 10, I can write that as 7 times 10 to the 9th power. Let's do the same thing in part B, except this time we're going to look at the population of Rhett's country. Okay, so his population, the country that he lived in, was that second value, 6,926,000. Well, when I round that so that I can then rewrite it easily using a power of 10, I would round it up to about 7 million. In scientific notation, that's equivalent to 7 times 10 to the 6th power. We're going to use both of those in part C, because it says approximately how many times greater was the population of the world in 2015 than Rhett's country. Okay, are we multiplying or are we dividing? How many times greater? Remember that example of having $10 in your pocket and your friend has $2. You have 5 times the amount that he has because you divided. So we're going to divide the population of the world by the population of the country that Rhett lives in. So we're estimating here. We're not giving the exact value. It says approximately. So I'm going to fill that in with the expressions that we just wrote in scientific notation. 7 times 10 to the 9th divided by 7 times 10 to the 6th. When I apply those properties of exponents and I regroup this problem, I'm first thinking, what is 7 divided by 7? And it's 1. And then I'm dividing 10 to the 9th by 10 to the 6th, which is 10 to the 3rd. So you could say it is about that many times greater 1 times 10 to the third, or it might make a little bit more sense to convert that to standard notation and say that it's about 1,000 times greater. The world population was about 1,000 times greater than the country that Rhett lived in. Let's work one more example. It says Vincent's dad drives a car that weighs about 3,980 pounds. A toy car in Vincent's toy box weighs, and then it lists that decimal. We're not really familiar with those place values, so it's just a really small weight in comparison to his dad's actual car. Now, part A, let's give an estimate of the weight of Vincent's dad's car. Okay, so here is the initial weight. Rounding that up to 4,000 helps me rewrite this as 4 times 10 to the third pounds. In part B, we're going to do the same thing here. And I would first round that to 0.08. So in scientific notation, I can write it as 8 times 10 to the negative second. The question asks approximately, so we know we're estimating, how many times heavier is the car that Vincent's dad drives than the toy car? So we know we're dividing the weight of his dad's car by the toy car. Using the expressions that we wrote, that will help us give the estimate. So the actual car that his dad drives, we round it as 4 times 10 to the third. And then the toy car would be 8 times 10 to the negative second. Now, when I divide the first part, the 4 divided by the 8, I get 5/10 or 1/2. And then 10 to the third divided by 10 to the negative second is 10 to the fifth power. Okay, now that's not actually in scientific notation because the first value is not between 1 and 10. So I could rewrite it as 5 times 10 to the fourth. And then again, it may be more helpful to actually think of this in standard notation. So 5 times 10 to the fourth is the same as 50,000. Okay, so the car that his dad drives is 50,000 times greater, or really 50,000 times heavier, I should say, than the toy car in his toy box.